Hello friends, my name is Anjali Patel. In this video, we will discuss the Leetcode question number 30, that is the substring with concatenation of all words. So here is the question given, okay, and here are some examples given, and these are some constraints, okay. So let's discuss the question in detail. So what the question says, you are given a string S and an array of strings that name is words. And one more important point, that all the strings of words are of the same length. And what is concatenated substring? Regarding this question, a concatenated substring in S is a substring that contains all the string of the permutation of the words. Okay. And here is an example given. Let's say there is an array words having the strings A, B, C, D, E, F. Then these are the concatenated substrings, which are formed by the concatenation of these given strings which are present inside the array in any order. Means every permutation of the concatenation of these strings. Okay, and what we have to return? We have to return the starting indices of all the concatenated substring in S. If S is something like A, B, C, D, E, F, G, H, then A, B, C, D, E, F is present here, which is starting at 0. So we have to return 0 in our answer. So let's understand it with an example in detail. So here I have taken an string. I have taken a string, and this string contain as bar foo foo the foo bar foo man. So let's do the indexing. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. Okay. And the words, the array words contain these strings foo, bar, foo. So let's find out the permutation which can be formed by concatenation of these strings. So it will be foo, bar, foo. Another may be bar, foo, foo. Another may be foo, foo, bar. So let's see that which concatenation is present here inside the string S as substring. So here it is present the bar foo foo, and here it is present the foo bar foo. So we will take the starting index of this substring in our answer. So 0, and here it is starting with index number 12, 0, 12. It will be our answer. Okay, so what are the constraints given? So the constraints are that length of the string can be goes up to 10 to the power 4, and least it will be less greater than or equal to 1, and least thing is of everyone is 1, and max can go the words length, means length of the array which containing substrings, means max to max 5000 strings can be present in that array which is given as words, and max length of every string that is present inside the array that can be up to 30, and it is a point to be noted that every string, that first string S and the all other strings which are present inside the array named as words are consisting of lowercase of English letters. Okay. Now let's see the approach. So what will be our approach? So what we have to do? We have to find the concatenated permutations of these words inside this S. So if we make the permutations foo, bar, foo, another one foo, foo, bar, another one bar, foo, foo. Okay. And now we have to search as these strings, these concatenated strings are present inside the S as substring or not. So how we will search? So we will go index by index in S, starting with this index 0. But up to what length we will go? So for determining that length, we will make a sliding window. So what will be the size of sliding window? So sliding window size, what will be that? That words. Words is an array. So what is size of it? So I am writing it array size. And what is the length of every string that is present inside that array? And in question it was given that these strings will be of same size. So what will be this? I am denoting it with n or k. Okay. And I will denote the size of s with n. Okay. So the size of the window, that sliding window size will be array into array size into k. How? That if there are number of the strings here which will be equal to array size, and size of every string that is present inside this array is k. So if I multiply it, then we will get the length of the concatenated string. Now we have to search that concatenated string inside the S as substring. So starting with 0, and we will go up to the length of sliding size, window size, which is here 9 in this case. So 0 up to here means 0 up to 8. We will go here and we will check that is this substring is concatenated substring. If it is, then return the true and we will store the 0. Then we will slide our sliding window by 1 point and so on. So let's see here. Okay. So, and for calculating, we will, for calculating or for determining that a substring is concatenated substring or not, we will require a hash table or hash map which contain the frequencies of all the strings which are present inside that array. So what is our array? Words equal to foo, bar, foo. Okay. So what will be the hash map? Foo with count 2 and bar with count 1. Okay. How we will implement this hash map? We will see in the code directly. Okay. Now, as we have this thing, now what we will do? We will try to find out that a substring of size, sliding window. So this is the sliding window of length 9. Okay. And we will put it here and check if this substring from this to this is a concatenated substring or not. Okay. So we will check for it. So how we will check? So how we will check? So we will create another function for this, that is concatenated, and this function will determine and provide us is it the concatenated substring or not. If yes, then it will return true, otherwise it will return false to us. Okay, so we will go from index 0 up to this index. I think this was 23. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, that's right. Okay, now we will make a loop which will go from 0 to up to 23. Okay, means that size of which will go up to the size of this string. Okay, so we will check for this. So is this substring is concatenated substring? So this function will tell us. Okay, if it is, then we will store this index 0 in our answer array. Then we will increase or slide this sliding window by 1, and then again by 1, then again by 1, and if we come and we keep checking that it concatenated substring or not. Then again by 1, then again by 1, again by 1, again by 1, then again by 1, again by 1, again by 1, again by 1. When we reach here, it will be found that yes, it is concatenated substring. So its index was 12. So that 0 and 12 will be stored in our answer. And then we again slide by 1, slide by 1, slide by 1, and keep checking. And these will come false as these are not present. So this is the algorithm discussion for this. Now what remained? That remained how to determine that a substring which is passed is concatenated substring or not. So let's see pseudocode for that too. Okay, so here I have written the pseudocode for it. So what we have to pass here? The map which I have maintained, the substring which to be checked, and we have to pass the word length. Word length is what? The length of a string which are present inside the array word. Means this foo, bar, foo. Okay. So this is the array which name as words. Okay, and the length of each one is here in is k, and I have denoted it with k. Okay, now what we have to do, and a map is also maintained, so we will also write this map as foo with count 2 and bar with count 2. So in this, let's check the two substrings. One this bar foo foo, and another one is uh, the foo bar. The foo bar. Okay. So let's write this string again here. So it will be what it was. Bar foo foo, the foo bar. Bar foo foo, the foo bar foo man. So let's take this substring. Okay. So this substring came here, and here we will run a loop j equal to 0 up to the size of this substring. So here in our case it is 9, and we will take jump of this k, means 3. So how it will be done? So what we will do? So we will found the word with the help of substring dot substr, and substr do what? Starting with this index and go up to this length. So the word will be starting from 0, index 0, and go up to 9 length. So 9 length will be up to here, up to 8. So it will be bar, foo, foo. Okay, not 9. The word length is k. So k, it will be 3. So it will be up to 3 length, means up to index 2. So it will be bar. Okay, and now we have to check that is this bar present inside map. If it is present, then we again check that if we reduce it by 1, does it is becoming -1. If it is becoming -1, then before reducing it was 0, which is equivalent to that it was not present. So if we check here that bar is present and bar count was 1, not 2. Yes, okay. And now if we decrease it by 1, it will become 0. So it is not becoming the -1. So we don't return the false, and we will go again to the for loop. Now the jump of j is 3. So the j will uh, goes to this index 3. So here the word will be form of the length 3, which will be foo. So we will check, is this foo is present inside map? Yes, it is present. Now decrease its length, its frequency by 1. So now let's check, is it -1? So no, it is not -1. So it will again go to the for loop. And now the j will again take the jump of the 3. So if 3, 4, 5, it will go up to 6. Okay. And here, starting from 6 and go up to 3 length, it will again find out the word foo. So we will check that is foo is present in the map. Yes, it is present. With what frequency? So after decreasing frequency, it will become 0. So it is becoming 0, not -1. So we don't return false, and it will then go again here. And now the j will take jump of 3 again, which will be 9. Okay, which will be 9, which is equal to the substring size. But here is the condition that j should be less than substring size. So we'll come out this condition, and we will come out this for loop and return true. Okay. Now let's see for the another example. Let's say I have taken uh, the foo bar, okay. So now what we have to do, that map frequency has been reduced, but we will require the proper map which was at starting. So we will require that proper map again. Okay, so we will make that proper map again, foo and bar with 1. So now the string which has been passed is the foo bar, the foo bar. Okay, so from 0 up to the length 3, the word is the. And if we will find that is it present inside the map or not? So no, it is not present. So if it is not present, then the flow will go to the else, and here it will return false. It will return false, that it is not present. So let's say if there is another string, let's say here bar. Okay, and we have to find out that bar foo is present. Bar foo, bar foo. If we check for this substring, then the j will start from 0 and it will go up to the size, up to the length k, that is 3. So the word will be formed as bar. Bar is present inside this map. Yes, it is present. Which with what count? That is present with 1 count. After reducing the count one time, it will become 0. Okay, so we don't return false, as it is not equal to -1, it is equal to 0. Again we go here and j will take the jump of 3 and here at 3. Now again this word will be from bar. We will check if it is present in the map. We will find out yes, it is present in the map. But when we decrease its frequency, it become -1. It become -1 means earlier it was present with the frequency 0, which is equivalent to that it is not present in that map. So we will return false. So all the cases have been covered now. I hope all of you have understood the approach. Now let's do the code. Okay. So how we will write the code? So first of all, I will find out the length of the string s. So int n equal to s dot size, and now find out the size of the array words. So int array size equal to words dot size. Again, now we will find out the size of one string that is present inside this array. So I am denoting it with k. K equal to words 0 dot size. Now let's initialize our answer vector. So vector int answer. Now we will maintain our HashMap. So declare an unordered map, which will be a type string, comma, int, and name as empty. And now fill this unordered map with the count of the string that are present inside the array, that array words. So for auto word inside the words and mp word plus plus. Okay, so now all material is prepared. Now let's run the for loop. So for int I equal to 0, comma I is less than n, that is size of the string is minus, and it will be less than equal to minus. What will be? We will minus the sliding window size. That if it is, let's say the sliding window size is 9, then if it will be 9 before that, then the whole substring will be covered, so we don't need to go further. So I haven't calculated that. Let's also calculate that. So what will be the sliding window size? Into sliding window size, it will be equal to array size multiply with k. Okay, so it will be n minus sliding window size and go to I plus plus. Now we have to check that the substring formed with it is the concatenated substring or not. So let's first form the substring. So let's write it string str substring equal to s dot substr starting with I and go up to the size of sliding window. Okay, and now we have to check. So if, and let's give that function name as is concatenated str is concatenated substr. Here we will pass the str, that map mp, and the size k. Okay, and if it is true, then we will push answer dot push back push back I and then return the answer. Return the answer. Okay. Now we have to implement this function. Let's copy it and it will return the bool type. Bool CTRL. Now string SSTR, and please don't pass the map by address. Pass it as the shallow copy, because if we will pass the deep copy, then the changes which will be made for one substring will be also reflected when we call it again for second substring. So please pass it as solo copy. So unordered map string comma int and mp and pass int k. Okay. And now let's apply the loop for int j equal to 0 and j is going up to SSTR dot size and taking jump of j plus equal to k. And if we will find the word string, word will be equal to SSTR dot substr starting with j and going up to the length of k. So it is word, and if we find is this word present in the map or not. So if mp dot find word does not equal to mp dot int, means it is find out. And again we will check if decreasing the mp word become -1, means it is equivalent to not present, return false. Okay, so it was the case when it is present if find out in map, but otherwise if it is not find out, then simply return false. And if for loop is completed successfully, means each word of length k has been found out. So that substring which we have passed is the concatenated substring. So return true. So I think this is fine. And now let's run it. Okay. Run it. So it has been accepted. Run it for more test cases. Okay, and submit it. So it is submitted, but the speed is not that optimal. So now again go here and see the time complexity. So in the main function, first of all, we are running a loop from I equal to 0 up to s dot size and minus the sliding window size, which approximately can be m, means size of the substring. And for each substring, we are running the j loop, which is going from 0 to this that substring size, which is equal to sliding window size, and taking jump of the k. Okay, and what is the sliding window size? That is the words length or words I have taken array. So array length into k, and as it is taking jump of k, so divide by k. So its time complexity will go up to n into array length. And if we see the constraints here, that s length and the words length. So the time complexity will be 10 to the power 4 into 5000. So how we can further optimize it? We can optimize it if we able to solve it 5000 into this k. I have taken this thing as k. That size of the string that present inside the array. So if we are able to solving this time complexity, then it can be further optimized. So this is also acceptable solution, but we can also further optimize this. So we will see the more optimized solution in the next video. Okay, I hope all of you have understood this concept and as well as the code. Okay.